Hi there. This video is going to go over how to find the least common multiple of a set of numbers. Let's look at the multiples of 6 and 8, starting with the number 6. The multiples of 6 would be 1 times 6, which is 6, 2 times 6, which is 12, 3 times 6, which is 18, 4 times 6, which is 24, and so forth. 36, 42, 48, 54, and so forth. Now if I look at the multiples of 8, 1 times 8 is 8, 2 times 8 is 16, 3 times 8 is 24, and then I have 32, 40, 48, 56, and so forth. I can write 64, and I've got quite a list. So I've got the multiples of 6 and the multiples of 8. Now what I want to do is see what multiples they have in common. Well, I see here's a common multiple, and I see here's another one, which means 6 goes into 24 and 6 goes into 48, but 8 goes into 24 and 8 goes into 48. Now what I'm interested in is the least common multiple. The least common multiple, which is often written LCM, is the least or smallest multiple that's common to both. So in this case, the LCM would be 24. So let's look at a few examples. I don't have to list out the multiples for some of the smaller numbers. I can simply ask the question, what number do 4 and 6 go into? And more specifically, what's the smallest number that 4 and 6 will go into? They will both go into 12, so the LCM is 12. The smallest number that 3 and 7 will go into is 21. And the smallest number that 20 and 30 will go into, that one I might need to write down some multiples, but I'm pretty confident that those will both go into 60, and that's the smallest number they'll go into. As the numbers get bigger, sometimes we need to use the prime factorization trees to figure out the LCM. So let's take a look at that. Let's take a look at the numbers 50 and 60. We're going to start by doing a factorization tree for both of them. So 50 is 5 times 10, that turns into 5, and then 2 times 5. 60 is 6 times 10, so that's 2 times 3, and 2 times 5. So now for the LCM, what we're going to do, the first thing we do is write down all of the factors that you see in the first number. So I'm going to write 5 times 2 times 5. Then I'm going to write down any of the factors over here that have not already been written down here. This tells me I need 2 2s, a 3, and a 5. Down here, I've got 1 2 and a 5. So I'm going to need to write down another 2 and a 3. Because here's how this works. These three numbers multiplied together give me 50, which means 50 is going to show up in my LCM. These 4 numbers multiplied together give me 60, which means 60 is also showing up in my LCM. If I multiply all those numbers together, and here's a quick way to do it. Here's a 10, 5 times 2 is 10. Here's another 10, 5 times 2 is 10. So 10 times 10 is 100, times 3 gives me an LCM of 300. Let's look at the numbers 20 and 36. 20 is 4 times 5, so that's 2 times 2 times 5. 36 is 6 times 6, so that's 2 times 3 and 2 times 3. So for my LCM, I'm going to write down everything that's in my first number, which is 2 times 2 times 5. Then I need to write down everything that's in this number if it's not already written. Now this says I need 2 2s and 2 3s. So it looks like I've already got the 2 2s, so I'm just going to need to put down the 2 3s and then multiply all those together, and I get 180. So thinking through this, we know that these three numbers give me the 20, and then the 3, the 3, the 2, and the 2 give me the 36. So both of the numbers have to show up in your LCM in factored form to get your final LCM. Now let's look at how we handle variables. If I do the prime factorization for x squared, that's x times x. For y to the 5th, it's going to be y, 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 y. Over on this one, I've got x to the 3rd, which is x, 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 and y to the 2nd, which is y times y. So I'm going to do the same thing I was doing before. I'm going to write down everything I have from the first term, which is x times x, and then I've got y multiplied 5 times. Then when I look at the second number over here, it says I need 3 x's and 2 y's. Well, the 2 y's are already taken care of, but I only have 2 x's, which means I'm going to have to write down one more x. So when I use exponential notation, I can write that as x to the 3rd, y to the 5th. Okay, let's look at one more example. This one has a combination of numerical factors and variables. So I've got the prime factorization of all 3 listed, and now I'm going to find my LCM. The first thing I do is write down everything I see from that first number. 2, 2, 2, m, n, n. Now the next one tells me I need 2 2's, 2 3's. I've got the 2's taken care of, but it looks like I'm going to need to add the 3's to my list. Then when I look at the variables, it tells me I need m 3 times. I've only got it once, so I need to put 2 more m's down. It says that I need 1 n, and that's covered. Now going over to the next number, it says I need 2 3's and an m. Well, here's 2 3's and an m. So there's nothing I have to add to my list because of this third term. But now I do need to multiply all of these together to see what I end up with for my final answer. When I multiply 2 times 2 times 2, that's 8, times 3 times 3, which is 9. So 8 times 9 is 72. And then I've got m multiplied 3 times, so I write m to the 3rd. And n is multiplied twice, so I write n to the 2nd. And my LCM is 72, m to the 3rd, n squared.